the test to use in order to determine if you have sphericity is Mauchly's test. And remember, we never want our assumptions, our tests of assumptions, to be significant. So we are hoping that when we look at the sig value for Mauchly's, right, it's a W value, when we look at that, we're hoping that the sig value is greater than 0.05. Now, what if the sig value is less than 0.05? In other words, what if it is significant, right? If it is significant, it means we do not have sphericity. We have a violation, all right? And violations, you got to figure, are never good, right? So why are they not good? Well, you might recall from a previous lecture that when we have a violation to an assumption, on the one hand, it actually makes it a little bit easier for our t-test or the ANOVA to be significant. And you're thinking, well, that's great because that's what we want. We want t-tests to be significant. We want ANOVAs to be significant. This is true, but we don't want to make a type 1 error. And if we have a violation, the risk of making a type 1 error goes up. So what do we do now? Well, we really want to make it a little bit more difficult for us to find a significant effect in the ANOVA. Okay, so Mauchly's is saying you do not have sphericity. And so in order to keep that risk of a type 1 error down for the ANOVA, we are going to make a correction. And this is where SPSS is nice because it actually gives us that correction. It's called Greenhouse Geisser. And Greenhouse Geisser, or just you can call it GG for short. So GG is a correction that's applied to the ANOVA results when you don't have sphericity. So you're never going to see GG done when you have a one-way independent ANOVA. Because remember, the assumptions for a one-way independent ANOVA are the core plus HOV. The assumptions for the repeated ANOVA are the core plus sphericity. And Greenhouse Geisser is the correction when you don't have sphericity. So you're only going to see this if you're running a one-way or a two-way or a three-way, but it has to be a repeated ANOVA. So what does the GG correction do? Well, it makes it a little bit harder in most cases for us to find significant results. In other words, when we look at our F value in the ANOVA, it's less likely to be significant. We're paying the price for the violation, right? We have to, give up something because of the violation. So what do we typically give up in order to make it a little bit more difficult to find a significant result to get this F to be significant? We're usually giving up degrees of freedom. That makes it a little harder for us to find significant results. But if you still find significant results with the GG, then you're really happy, right? Because you still have significant results and you've lowered your risk of a type 1 error. All right. So if Mauchly's test is not significant, this is good, right? Look at the ANOVA for sphericity assumed. All right. So again, if let's say the F in the ANOVA is significant, then you're going to have to look at GG. If the F in the ANOVA is not significant, sorry, did I say? Oh gosh, I am so sorry. Here for the Greenhouse Geisser, you're looking at Mauchly's test. You're looking at the W value. I am so sorry. So you look at that W value. And if it is significant, then you look at Greenhouse Geisser results. On the other hand, if Mauchly's test is not significant, okay, so that W value is not significant, this is good, we're happy. Now you look at the results for sphericity assumed.